Okay, so for sort of our final trigonometry assignment, we're going to try and take some problems from challenge math, from middle school challenge math, and use them, and use them in Wolfram. So we see here are basically the functions that we need. So we need to say sine, cosine, or tan with the keyword degree. So if you want to have the cosine of 30 degrees, you say 30 degrees. Otherwise, you get it in radians, which is something different. So let's say that you know the ratio of the angles. Okay, so you know that it's, say, 1 to the square root of 2. So then you say, well, what angle is that? So you can say, if that was my sine, have that ratio, then the arc sine will give me the angle. But it won't give me what I want unless I say slash degree and full simplify. And I think that rounds it off slightly. Okay, so what we're going to do is we're going to try and use the Wolfram and make a notebook that does this. Now, I have the advantage in that I can paste very easily between these two, so I'm going to try and do that. And so I'm going to go into my explain everything and go back and save and create a new one and just do the drawing. And so this, it's not necessarily what you can do right now, but as you get further along and have a little more resources, this would be, a good way to get set up. Well, we'll see which color background works. This fire department needs to order a ladder that will reach to the top of the tallest building, so the 180-foot hotel. Okay, so I'll draw a hotel up to here, 180 feet. And for safety reasons, the angle to the ground must be 65. Now, of course, you sort of wonder what do they mean by angle to the ground, but I'm going to assume that it's down at the base. What's the shortest ladder that they can use? Okay, and so I've got my drawing, so I've got that the sine of 65 degrees is the ratio of the 180 to the ladder. Okay. And I'm going to see, so let me see if I can go back and forth. So I'm going to explain everything, and I'm going to put that, I'm going to copy, and now I'm going to go and see if I can copy that. So if I copy that, I wonder, so then I go in here, and I say, can I paste it? Yeah, and so there it is. So there's my little diagram. Okay, so there's my diagram, and it says, let's let's have 65 feet. 65 degrees will be the ratio of the 180 to the hypotenuse. Okay, so when we have that, what do we have? Okay, so we're going to divide. You can see here is that we want to get a hypotenuse, so we're going to divide 180 by the sine. Okay. And so we look up here and we say, well, okay, we got sine. And so what you want to do as much as you can is copy when you're doing anything in computer programming. So copy something that works. Okay, so you got to get the sign there that says that you're using input instead of just text. So we're going to do sine, and this time it's 65 degrees. Okay. And we're dividing, so I think it's 180 divided by sine of 65 degrees. Okay, so let's see what happens when we do that. Okay. So that didn't work, right? And so you think, well, what did I do wrong here? So then you say, so when you're doing something like this, you say, well, go down to smaller pieces and say, does that, so you say sine, that doesn't look right either. So you say, well, maybe if I do /n, right? So /n, and try that. Okay, so that looks a little better, right? So now, say, okay, I'm going to do 180 divided by, and then maybe, just to be safe, put that all in parentheses and try it. Okay, so 198. So the ladder has to be 198 at that angle. Okay, so does that make sense? It has to be a bit longer, but at that angle, seems okay. All right, so here we've already got, in the second one, we've already got our plane is flying, dragging a 1 mile long wire that has a weight attached to it. So it's deflected back at 22-degree angle. Okay, so I think that this is the 22-degree angle, is at the plane. Okay. And the weight is skimming above the water, so how high is the plane? Okay, so if this is a mile, okay, so then you have to decide, do you want to do it as a mile or as in feet? So maybe we'll do it in feet. Okay, so it looks like we want to find out the cosine. Okay, so we want to find out the cosine. So the thing we want, 2x. Okay, and so now we can multiply. Okay, so let's grab what we have, and so we'll go down in here. Okay, and we click and we get what we want there, which is that. And so let's put the whole thing in quotes. So that cosine, and then if we want to do feet, we'll do times 5,280. Okay, so that's the mile wire, so the hypotenuse. So if multiply by hypotenuse, it's going to be some part of that. And let's see what we get. So we get 4,500 feet. All right, so we're able to use the cosine. So there aren't that many variations really on these problems, right? Is that either you're going to multiply or divide if you know the angle. So let's say we can figure out this one. Tom sees an enormous thundercloud, and he sees lightning flash, and here's thunder 15 seconds later. So what you have to remember, of course, is that sound travels at 1 mile in 5 seconds. Okay, so 3 miles in 15 seconds. Okay, so we say we got that. All right. And then his angle of sight to the top of the cloud is 65 degrees again. Okay. And so how high is the top? So this 3 miles, you kind of suspect that means distance along the ground. Okay. So distance along the ground and the line of sight to the top, 65 degrees. So that is the hypotenuse, distance along the ground. So the adjacent side is 3 miles, and we want to find out how high it is. All right, so that's one where so did we have one like that before? So it's kind of like this, except now we have cosine. So we say, okay, so know what I'm doing, I'm just trying to find something that worked. Okay. So in this case, it's the 3 miles is along the ground. So 3 miles divided by, and in this case, the cosine of 65 degrees. Okay, so it's 7 miles. So it's 7 miles up. So the storm's fairly high up in the sky. Okay, so let's just draw that one out real quick and take a look, right? So what we're saying is that we have 3 miles here, and we don't know how high up it is to the cloud. Okay? So this is what we don't know. And we know the angle is 65 degrees. And so we say that the cosine of 65 degrees equals 3 miles to the to cloud. And so to figure that out, then we do 3 miles divided by cosine of 65 degrees. And so now if I grab that, so So I grab this, and then I make a copy. And let's see if I can put that in here, so I'll try and paste it in. Alright, so I'll add a place to paste it in. So just so I don't oh shoot, so I'm not sure where it's getting pasted in. It seemed like it was working. Oh, yeah. So it got pasted in here. Let's see if I can make it a little bigger. It's not working on that background very well either. Let me try one more time. Try a different background. Oh, actually I can just go back and just change the background. Change it to a white background. And then change the ink to black. Okay, so let's try it. So we've got, let's see if this diagram works better. So we say, okay, it's 3 miles. It's 65 degrees. And we don't know that. So the cosine of 65 degrees is 3 miles to what we don't know. So we do 3 miles divided by cosine of 65 to get that. So then, what's that? All right, we've got something. And we'll make a copy of it. Okay, so now we'll say, all right, we're going to paste in, and we'll paste it in. Okay, so now at least we can see it. Okay, so here it is, and we make it bigger. Okay, and there it is. So we say 65 degrees, 3 miles. So cosine is that, and so that's how I would do it. Let's see if we can. So you can see the problem is temporary problem. When he's 300 feet away, his sight to the top of the tree. Okay, so here's one where you want to think about it a little bit. And so, what does it mean? Why do they care that he's 5 feet tall? Right? And so you say, well, they care that he's 5 feet tall, 1, 2, 3, 4, 5, right? So that his eye is 5 feet above the ground. Right? And so he's going to estimate 5 feet below what it really is. And so his angle, so he's 300 feet away, so that's on the ground, 300 feet away. And his angle is 18 degrees. Okay. And we want to know how tall it is, but we're going to have to add that 5 feet that he is above the ground. Okay, so let's see if we can just copy this. So we copy it. And let's see if it pasted in. It didn't paste in, but if I say There's a more laborious way of doing this that I could do. Okay, so I just control V and that works. Alright, so there's a diagram. So this is the thing, right, is that you're 5 feet you're 5 feet from the ground. Okay? So then your angle is there. So you want to have the tangent of 18 degrees, but then you're going to add 5 to it. Okay? So let's see if we can find tangent up here. And then we have to decide what we're going to divide by or multiply by tangent. And it's going to be 18 degrees. So we come down here. And try and add in. And we say, okay, so the tangent of, in this case, 18 degrees, it's what we want to know times 300. Okay. So we're going to multiply this by 300. Okay, so let's do that first. Alright, so if something like this is happening, what you can do is you just go to Format and you say, well, it says it's input. And so it looks good. That looks good, but nothing's happening. Right? So try once again, Shift, Enter. Okay, nothing happened. And so I try and add a new guy in here. So I put in a new one. Okay. And see how this one looks a little strange with the dark? So who knows what's going on there. So let's try this one. Tan 18 degrees and times 300. Doesn't seem that hard, right? Doesn't seem like Wolfram wouldn't be able to do this. And so, you know, if you're in the middle of something like this, you go up and say, well, let's see something else that worked and see if I can divide like that. It looks like we've kind of lost communication with our, yeah. So Wolfram's you can see Wolfram's having some problems. But, so we'll end this video and